Hello everyone, this video will be a basic intro to quadratic functions. Um, at this point, we should be pretty familiar with quadratic functions, and when we have a quadratic function, this is a quadratic function in standard form. Y is equal to ax squared plus bx plus c, where of course my a cannot be 0, so a, b, c, they are just any constant, any value, but a cannot be 0, because if a becomes 0, then that whole thing goes away. We wouldn't have a quadratic function. Okay, so this is the standard form of a quadratic function. So here I have an example here. I have y is equal to x squared minus 6x plus 5, and I'm going to show the graph. Okay, so this is the blue line over here. That is the graph of my equation. Y is equal to x squared minus 6x plus 5. So this parabola, this quadratic function, is opening upwards. As you can see, these two ends, it keeps on going up. It does not stop. So this parabola opens upwards, and sometimes the parabola will open downwards. Right. So how do I know if my parabola opens upwards or not, or open downwards? And that's a very useful information for us to kind of have a good idea of how the parabola looks like. So here's the trick. So in this case, if I just match this equation, y is equal to x squared plus bx plus c, if I match that with the equation that I have here, my a is equal to 1. My a is equal to 1. My b is equal to negative 6. And my c is equal to 5. Alright, so those are my values. So right now, if we just want to know if the parabola opens up or down, I'm only going to look at the leading coefficient, which right now is a 1. My a is equal to 1. Which is a positive number, right? My a over here is equal to 1, which is a positive number, so it is going to open up. Okay? So if the leading coefficient is a positive number, the parabola will open up. So let's change this a little bit. Let's say if I have, let's turn off the blue graph. Let's say I have y is equal to negative 2x squared. I'm just going to make something up right now. Plus 3x minus 2. Okay, so as you guys can see, I have this parabola, and since my leading coefficient is a negative number, it's negative 2, right? My leading coefficient is negative 2. My graph opens down. Okay, so we look at a, which is my leading coefficient, to know if my graph is going to open up or down. Okay. Other information that we should know by now are, for example, the x-intercepts, right? So I have two x-intercepts here, which are 1, 0 and 5, 0. And we can get these values, the 1 and the 5, by simply applying quadratic formula, right? And we talk about this in class as well. So x-intercepts is where the graph cuts the x-axis. The graph cuts the x-axis at these 2 points, so it's called the x-intercept. So of course, the y-coordinates for the x-intercept will be 0, right? Now, so if I have my two x-intercepts here, then I should also have a y-intercept, right? A y-intercept where my line cuts the y-axis. In this case, it is 0, 5. Since this y-intercept is where my graph cuts my y-axis, so it would make sense to have my x-coordinate as 0. And in this case, when my x is equal to 0, when I put my 0 in here, I would have y is equal to 0 squared minus 6 times 0 plus 5, which gives me, so that this is 0, this is 0, so my y, when my x is equal to 0, my y value is just 5. So that's it, right? So yeah, so this is my x-intercept 1, 0, my x-intercept 5, 0, and my y-intercept 0, 5. And we also talked about when do we have two x-intercepts, when do we have one x-intercept, or when do we have no x-intercept. So that's when we have to look at the discriminant. We talk about that in class as well. If you're not sure, please talk to me and I'll help you out. Okay, so another property, another special property about quadratic functions, graphs of quadratic functions, is that there is always going to be a point, right? So in this case, since my graph is opening upwards, my parabola is opening upwards, I will have a minimum point. This is where, so as you can see here, on the left hand side, the slope become less and less steep, and when it gets to this point, it is basically flat. And then after passing through that point, the slope picks up again, right? So yeah, so the vertex, we call this point the vertex. Okay, I'm going to type it up here. Vertex, V-E-R-T-E-X. That is vertex, and it is a special point on a parabola. So right now my graph is opening upwards. That's why my vertex is a minimum point. Okay, so let's say if my I'm going to change my equation. Let's say I want a graph that opens downwards. All I have to do, put a negative in the front. So now there you go. My graph opens downwards, right? My graph opens downwards, and my vertex is no longer a minimum point, but a maximum point. Okay. Maybe I should put down both equations so you guys can see what's the difference. Just give me 1 minute here. Alright, so the blue line on the right, this one has a vertex, and that vertex, so since this line opens up, the vertex is a minimum point. And for the black parabola, which opens down because of the negative, also has a vertex. However, that vertex is a maximum point. Okay, so when the graph opens down, we have a maximum point. The vertex is the maximum point. When the parabola opens up, the vertex is a minimum point. Okay, all right. So for now, I hope you guys got the idea of vertex. All right. So how do you find vertex? Let's say today I do not have the graph. Okay, let's say the graph is not there. I am only given the equation, and I need to find the vertex. Okay, so for now we we know that the vertex is at 3, -4, and I need to find that point without looking at the graph. So I will have to find that 3, -4 algebraically. So this is kind of a pretty simple and straightforward way to do this. I say I'm going to use B as my vertex, and it's going to be a point. So it's going to be some x. Since it's a point, I must have x and y. Right? So if I want to find the x coordinate, and I'm always going to start with finding my x coordinate for my vertex. To find the x coordinate of my vertex, this is the formula: -b over 2a. Okay, -b over 2a. So in this case, my ABC, let's write down. My A is equal to 1. My B is equal to -6. And my C is equal to 5. Right? Let me pull this up. Okay, so but my B is -6. Let me change that. So the B is no longer there. -6. My A is equal to 1. So instead of that A, I'm going to change that to 1. And the negative stays in the front. And I'll figure out what's my y coordinate later on. So let's find my x coordinate first. Alright, so my vertex is a point, either minimum or maximum. Alright, so in this case, my leading coefficient is positive, so I know this is going to be my minimum. -6 becomes 6 over 2, I have 3. So my x coordinate of my vertex is 3. But I still don't know what my y coordinate is. So how do I find the y coordinate? Think about that. Okay, so it's straightforward. If given the equation, right, the equation is x squared minus 6x plus 5. As long as I can put any x values in there, the equation is going to give me a y value, right? So all I have to do with this 3 in order for me to get the y is to sub the 3 in there. So for me to find my y value, y would be equal to 3 squared minus 6 times 3 plus 5. And that gives me, what does that give me? That's 9 minus 18 plus 5, which is 9 minus 18 plus gives us negative 4, right? So negative 4. This is equal to negative 4. So there you go. So that's my y value. This is my y value. So now I just found my y coordinate of my vertex, which was exactly what we had earlier on, 3, negative 4. Okay. So this could be a little bit more confusing here because we actually have more steps to do. Feel free to pause the video and replay this section about vertex, finding vertex, and what does vertex mean. And make sure you know when is the vertex a maximum point, when is your vertex a minimum point. These are very important. Okay, good luck, and I'll see you guys.